Hi folks, we're going to take a look at page 208, number 15, and it says determine the minimal distance from the point negative 3, 3 to the curve given by y equals x minus 3 squared. Okay, so again, as I do pretty much in every one of these questions, first thing I want to do is set up a diagram, and in this case here, this is an analytic geometry problem. So we've got, I'm just going to do a quick sketch here of y equals x minus 3 squared. Okay, so we know that it's just a x squared shifted over to the right by 3 units. Okay, and we want to find the minimum distance between negative 3, 3. So say this is negative 3, 3, and we want to find the minimum distance from that point to any point on the curve. Okay, so again, I haven't necessarily drawn the minimum distance, but I just want something that will relate the distance of the given point to some point on the line. On the parabola in this case here. Okay, and what we want to minimize is the distance between them. Okay, so this is where we want to think about the distance formula between 2 points. So we've got negative 3, 3. Now I can call this point xy since it's variable, but I actually know how the x and y components are themselves related to each other. That if I call this x component x, the y component will be x minus 3 squared. Okay? So the idea here is to minimize the variables that I'm using, because if I can write an equation that right off the bat is written in terms of one variable, saves me a lot of trouble. Okay, so essentially what we're doing is we're finding the distance between this given point and this variable point, and we're trying to determine which x value is going to give us the minimum distance. And in fact, what they want is the distance itself. So let's start by having a formula for the distance. So d is just equal to, and now you have to remember the distance formula, or if you don't remember it, you can kind of figure it out and realize that you use Pythagoras. So you're taking essentially the difference of the x's, that will be one side of this right angle triangle, and the differences in the y's will be another side of the right angle triangle. So it's the square root of x2 minus x1. So I'll write it as x minus negative 3. So x plus 3 squared. Okay, and then plus y2 minus y1. So this will be x minus 3 squared minus 3 squared. Okay, so here we have a function for the distance between the 2 points, okay, given in terms of one variable. And so now we can go ahead and, go to our calculus portion of solving this problem. Okay, so let's take a look here. Let's take the derivative here with respect to x. Okay, so now you're kind of seeing why I chose to use capital D for the distance, because I didn't want it to interfere with my derivative notation. Okay, so this again is this expression all to the 1/2. So it's 1/2 times x plus 3 squared plus x minus 3 squared minus 3 squared to the negative 1/2. Okay, and now I just have to take the derivative of the inside. Now, I'm really trying as much as possible to avoid having to square this expression if I can. So I'm going to see if I can keep going without doing it as much as I can. Okay. The other thing you notice is that all this is going to go into the denominator because of the negative 1/2. So I'm not interested necessarily in this expression. That's going to end up in the denominator. What I'm interested in is what's going to make this derivative equal to 0. So it's the numerator that I'm interested in. So this is the part now where I want to carefully take the derivative of the expression in the square root. And I'm going to make use of our good friend, the chain rule, as much as I can. So instead of multiplying this out, I'm just going to apply the chain rule. So the derivative of x plus 3 squared is 2 times x plus 3 times the derivative of x plus 3, which is just 1. Okay? Plus, now I'm going to take the derivative of this thing using the chain rule. So first I'm going to take 2 times this expression here. So 2 times x x minus 3 squared minus 3. Okay, and then I'm going to take the derivative of the inside. So the minus 3, that's just a constant. That won't change anything. So the derivative here is just going to be 2 times x minus 3 to the 1. And here times the derivative of x minus 3, which is just 1. Okay, and close off that big bracket. Okay, so let's see if this is useful for me. And already it looks better because while I still have this whole expression that I'm going to have to expand, it's no longer squared. Okay, so I think this will save me a lot of algebra. So while I'm writing it out, let me start simplifying the numerator. So here we've got 2x plus 6. Okay, and then here you've got the 2 times 2 is 4, so plus 4 times, well, this now we'll have to save for later on. So here we've got the x minus 3, okay, and we've got the x minus 3 squared minus 3, okay. Still a little complicated, but certainly a lot better than what I had before. And divided by this whole thing in the square root. So I'm going to be a little lazy here, and I'm just going to use the ditto signs, okay, since this expression really isn't going to interest me at all because it's in the denominator. Okay, so now I got to do some work to simplify the numerator. So here we've got the 2x plus 6, nothing to do with that yet. Okay, plus, I suppose I can multiply this out. So 4x minus 3, sorry, 4x minus 12. Okay, be very careful. Make sure that's in brackets because this has to now multiply. And let me square this binomial. So it's x squared minus 2 times the first and last. So 2 times negative 3x. So minus 6x. And then this is going to be, I'm going to have a plus 9 minus 3. So I'm just going to try to save myself from having to rewrite a whole line if I can do some of this in my head. Okay, all over 2 times that big square root. Okay. So let's keep going now in the numerator. So 2x plus 6, and here what do we have? Well, we have 4x times x cubed. Okay, so plus 4x cubed. Okay, then 4 times negative 6x, so that's minus 24x squared. 4x times 6 plus 24x. And now let's deal with the negative 12, so negative 12x squared. This will be positive 6 times 12 is 72, so plus 72x, and then negative 12 times 6, so minus 72. Okay, so again, lots of little calculations to do, but just try to be as careful as you can. So let's bring everything together here. So what do we have? Well, let's go. We've got our 4x cubed. Okay, let's bring our x squareds together. So we've got negative 24 minus 12. So that's minus 36x squared. Okay, let's get our x's. So 2x plus 24x, so 26x plus 72. So 72, 82, 92 plus 6, 98. So plus 98x. And then here we've got 6 minus 62. No, sorry, 6 minus 72. So that is negative 66. Okay. Now, remember what we want is we need this to be equal to 0. Okay. So we essentially have to solve the numerator equal to 0. So I'm going to divide, looks like everything is divisible by 2. Not 4, since 66 won't be divisible by 4. So I'll divide, so multiply this to the other side, just 0. So again, as we suspected, that denominator doesn't affect anything. And I'll divide both sides by 2. So I'm left with 0 equals 2x squared minus 18, sorry, cubed. This should have been 4x cubed. Sorry about that. Hopefully you noticed that. Okay. Minus 18x squared plus 49x minus 33. Okay, so now we're going to have to factor this, so we're going to have to use the factor theorem because I'm taking a look at the first two and the last two terms, and grouping is not looking too promising. So certainly you should think about grouping, but that doesn't look like it's going to work here. Okay, so let's test, let's test the easy ones. Hopefully that'll work. Let's test x equals 1. So what do we have? We have 2 minus 18 is negative 16 plus 49. You know what? I think this is going to work, but let's just not take any chances and use our calculator. So again, we have 2 minus 18 plus 49 minus 33. And lo and behold, I guess somebody thought ahead to make this a fairly easy problem, given that we had to use the factor theorem. So we know that x minus 1 will be a factor of this polynomial. So since it's linear, let me use what's that called? Synthetic division to find the quadratic factor. So here 1. Okay, so good practice on synthetic division. So 2, negative 18, 49, negative 33. Okay, so here 2 comes down. 1 times 2 is 2. So negative 18 plus 2 is negative 16. Okay, here we got negative 16. So 49 minus 16 is equal to 33. And of course, when we put the 33 here, negative 33 plus 33 is 0. It is worth checking that just to make sure you didn't make a mistake. Okay, because if this didn't turn out to be 0, then that wouldn't be a factor. Okay, so our quadratic factor that's left over is 2x squared minus 16x plus 33. Okay, and so now we have to try to factor this thing. But before I go try to factor that or use the quadratic formula, let me just use the discriminant to check to see if it is indeed, if it has any zeros. Okay, so here discriminant b squared minus 4ac. So negative 16 squared minus 4 times 2 times 33. And I think that has a good chance of being negative. So let's check that out. Okay, 16 squared minus 4 times 2 times 33, and it's negative 8. So that, again, makes life simpler for us because we know this will never be equal to 0. So the only possible answer here is x equals 1. Okay, so this is our only critical point. What we need to check is whether this is going to be a minimum or not. Okay, so here, let's put in 1. So let's go back to our derivative. I guess the simplest form to our derivative would have been this one here. So we know that the denominator's always just going to be positive. So let's say we just put in x equals 0. Okay, nice and easy. So we end up with negative 66. So we have negative. And let's put in x equals 2. Okay, so let's just calculate that to be precise. So we've got 4x cubed, so 4 times 2 cubed is 8, minus 36 times 2 squared is 4, plus 98 times 2, minus 66, and we get a positive number. Okay? Again, I didn't worry about the denominator because the denominator is always positive. Therefore, this represents a minimum. Okay? So now we know that it's at x equals 1. Actually, looks pretty close to where I drew it. At x equals 1 is where the distance is going to be a minimum. Okay? Now you can actually think about how this would look. Think about it geometrically. What would be special about this point? And I'll give you a hint. It has to do with the slope of the tangent and the line that joins them. Okay? So think about what should be special about those two lines for this distance to be a minimum. Okay? Brings up some concepts from our vectors portion. Okay? However, I believe the question here was, let's check again. The question is, determine the minimal distance, okay? So what we actually have to do is to determine the distance. So we go back here and we're going to input 1 into our formula, okay? So we're looking for the distance when x is equal to 1, okay? I just meant to write 1, but I guess I went a little too quickly. So that's the square root of 1 plus 3 squared plus 1 minus 3 squared minus 3 squared, okay? And we'll see if this is a perfect root or not. Okay, so let's carefully calculate that. So this is 1 plus 3, so 4 squared plus, and in brackets I will do, so this is 1 minus 3 is negative 2 squared, or just 2 squared. So 4 minus 3, and of course that's squared, but that'll just be 1, equals, and 17. So we have square root of 17. Okay. Now notice here there was no application context to this question, so the expectation is that you give us an exact answer. Okay. So again, this is a bit of a tougher problem. That's why I guess it turned up in the Part C section of this homework section. Okay, but just to kind of go back and review what we did. Okay. Let's see if we can, there you go. So if we take a look, the first thing we did is we drew a diagram to represent the situation. We realized that we needed to use our distance formula, created our equation, did the calculus, and then finally answered the actual question. Okay, so very nice question, certainly a little complex on the algebra side, but sort of brought together a lot of the concepts we've been looking at. Okay, that's it.